Okay, so now we're going to continue to solve equations. So this is still Module 3. And we're still talking about Section 2.2, which is solving equations. And we're going to generalize. This is the procedure for solving linear equations. And this is the type of equation that we've been working with. They were all called linear equations, okay? So the first thing we want to do is simplify each side of the equation before moving anything across the equal sign. Okay, so we're going to simplify each side of the equation. So remember, equations have sides, right? And it's the left side and the right side of the equal sign. And we're going to simplify each side before moving terms across the equal sign. All right, meaning if you see any like terms on one side, simplify those first. Right, so that means that we want to clear any parentheses. Right, we use the distributive property. And then we want to combine like terms. Once we've done that and each side can't be simplified any further, then we're going to start to use the addition or subtraction properties of equality to collect. So we're going to get all the variable terms on one side and the constants on the other side. So to collect variable terms on one side. And again, we're talking about one side of the equal sign, right? And then the constants on the other side. And then the last thing we always do is either multiply or divide. Right? So we don't multiply or divide first until you only have one term on the left side and one term on the right side. So we're going to use multiplication or division property of equality to make the coefficient of the variable 1. And don't forget, the very, very last thing we do is we check our answers. Because when you're solving equations, there's absolutely no reason why you should get an answer wrong, because you can always check. Okay, so let's do a couple examples. So I'm going to ask you to solve 28 equals 4 times the quantity v minus 2 plus 8v. Okay, so remember, the first thing we need to do is simplify as much as we can before we start moving things back and forth across the equal sign. So we need to clear our parentheses, and we see we have this 4 that needs to get distributed out, right? So we have 4 times v, so that gives me 4v. And then we have 4 times negative 2, that gives me a negative 8. Okay. Plus 8v. So that still stays. Right? So the only thing I did was I cleared my parentheses by distributing my 4. And I still have 28 equals, right? That didn't change at all. So I can't simplify anything on the left side, but I certainly can on the right side, right? I have an 4v plus an 8v. So that gives me 12v minus 8, and I have 28 on the side. Well, I'm almost there, right? So now on my right-hand side, I have one term that has my variable in it. That's it, in the entire equation. So I want to isolate that. What do I want to do? I'm subtracting 8 from it, so I'm going to add 8 on this side. Now I can start moving things across, right? So I add 8 over here to get rid of this minus 8, so I have to add 8 on this side. So now these guys disappear, and I get 36 equals 12v. And remember, the last thing I always do is either use multiplication or division properties of equality. So here I'm going to try to get the coefficient of v to be 1. So 12 divided by 12 will give me 1. Right? So what I do to one side, I do to the other side. And I get 3 equals v. Right? That's the same as saying v equals 3. So that's my answer. And then I can check. Right, so my original question was 28. My original equation was 28 equals 4 times the quantity v minus 2 plus 8v. And we're saying v equals 3. So let's check. Does 28 equal 4 times 3 minus 2 plus 8 times 3? So I get 28. Does that equal 4 times 1 plus 24? And I get 28 equals 28. So I know I did the problem correctly. Okay, let's try another one. Solve. 12 plus 2 equals 7 times the quantity 3 minus y. Okay, so I look on either side. I can simplify, right? Over here I can simplify 12 plus 2 because they're like terms, so I have 14 equals. And on the right side I can distribute. I have 7 times 3 gives me 21. 7 times negative y gives me minus 7y. Okay. So what term has the variable in it? Well, it's my y. And I'm going to isolate it along with its sign. And I'm going to say negative 7y. I want to get that by itself. So I need to get rid of this 21. Well, even though I don't have a sign out here, that's assumed that it's positive, right? So I want to get rid of it on that side. So I'm going to subtract 21 from both sides. So these go away. And I have negative 7y equals negative 7. The last thing I do is divide by the coefficient of the variable, and I get y equals 1. Right, and again we can check. Our original problem was 12 plus 2 equals 7 times 3 minus y. Well, if y is 1, 14 equals 7 times 3 minus 1. 14 equals 7 times 2. So 14 equals 14, and sure enough, I got the right answer. Okay. Let's do another one. I have solve. Negative 6 times x minus 6 equals 2x minus 12. So before I start moving things around, I got to clear my parentheses, use the distributive property. Negative 6 times x is negative 6x. Negative 6 times negative 6 is plus 36 equals 2x minus 12. That can't be simplified any further, right? Because they're two different terms. So here I can't simplify anything on the left, I can't simplify anything on the right, so I'm going to start moving things across. Now it doesn't matter what direction I move, I can collect all my constants on the left and my variables on the right, or vice versa. I can collect my variables on the left and my constants on the right. If I look over here, I see that I have a negative 6x, and over here I have a positive 2. Well, I can think to myself, if I add positive 6, if I add a 6x over to this side, my constant terms stay positive, right? And I can get rid of that negative 6x over here. So I have positive 36 equals 8x minus 12. Now I want to isolate my 8x, and I have this minus 12 here, so I do the opposite. So I add 12 to both sides. So I get 8x equals 48. And the last thing I do is divide by the coefficient. So I get x equals 6. Or x equals 6. Okay. All right. So sometimes you might not, you might have fractions in your equation. So I would say don't worry about the fact that you have fractions. We're going to do something called clearing the denominator. So I have negative 6/7 minus 1/3 v equals negative 3/2. So what I want to do is clear the fractions by multiplying everything, every term, by the least common denominator. Okay, so if I look at what's the LCD of 7, 3, and 2. Okay, it's 42. So what I need to do is multiply every single term by 42. So how many terms do I have? Well, I have a term here, right? I have a term here, and I have a term here. So I'm going to rewrite this. I'm going to say negative 6/7 minus 1/3 v equals 3/2, or negative 3/2. And what I want to do is multiply each one of these by 42/1. And what that does is, because that's the least common denominator, they cancel out, and I don't have to work with fractions anymore. So 7 goes into 7 once, 7 goes into 42 6 times. So in this group right here, I have 6 times negative 6. That gives me negative 36. 3 goes into 3 once. 3 goes into 42 14 times. So my denominators are all 1s. That means it basically goes away. And I have a minus 14b. And the last thing I have here is 2 goes into 2 once. 2 goes into 42 21 times. So I have negative 63. Now it becomes a straightforward problem, like what we've been working with before. So I'm going to take, if I look on either side, I can't simplify anymore. So I'm going to add 36, add 36 to both sides, and I get negative 14 v equals, let's see, 7 equals 27. And then the last thing I do is I divide, this should be negative 27, right? So I divide everything through by negative 14, divide by negative 14, and I get v equals positive 27/14.